function, I know what you're thinking. Maybe I don't know. You're tempted perhaps to do the quotient rule, to use the quotient rule.
But don't.
You could.
You could.
I mean, of course you could.
Sure.
But, you know, again, all the rules work on every single function. That's why math is so beautiful. But it's nice to use the simplest possible rule. So let's rewrite this guy. I'm going to bring this x upstairs. So I have negative 2 over 3. I'm moving that guy upstairs. That is really x to the negative 1/2.
Right.
This is not the derivative.
No.
I just rewrote it.
You just rewrote it. That 1/2 is the square root.
That's right. And I moved it upstairs so it's a negative.
Beautiful.
Remember, when you take the derivative, you want some number x to some power.
If you possibly can.
If possible.
Yeah.
Then you can use the power rule.
And here we go.
So I have 1/2 times negative 2/3. Again, remember, multiply the tops, multiply the bottoms. Y prime equals, this is going to be positive 2/6 x to the, I have to subtract 1 from negative 1/2. That is negative 3/2. And now I can just simplify this a little bit, and I'm going to move this negative exponent back downstairs.
Okay. So you want the derivative written with positive exponents.
I do.
And
That's how I want it. That's right.
Hey, let's do it then.
This, of course, is 1/3. I'm going to move this guy back downstairs. It's down there with the 3. And it is x to the positive 3/2 again. And that is my derivative.
There's your derivative.
That's it. Way easier than using the quotient rule.
Yes. If you wanted to, could you write that as in radical form?
I could.
You could.
I could. I like fractional exponents. They just say so much more to me than radicals.
Yes,
somehow.
I'm with
It's
you.
consistent.
Yeah.
All right. So let's find the derivative of this guy. Is it all right that I'm kind of working in this
I
kooky
think
way
so.
here?
I think we can figure this out.
Again, I'm going to rewrite it. This is not the derivative, Miss Stewart.
No, it's not.
Wait, is this the derivative?
No, you just rewrote it.
Yes, I just rewrote it. I just kind of slid the 4 off the top. You know, on the side is the same thing as
That's right.
on the top.
Yes.
Yes.
Dividing something by 4 is the same as multiplying it by 1/4, or so they say.
Yes, so they say. Anyway, so let's take the derivative. 4 times 1/4, also known as 4/4 or 1.
Yeah.
Yeah,
Love that.
F prime of x equals 1x cubed. Am I done?
You're done!
I am done.
Oh my gosh, that was so easy.
It is so easy, but sometimes something about this messes students up.
Oh.
I think if you rewrite it like this, you can't go wrong. How can you go wrong?
Go wrong.
And that is it.
Beautiful.
2 more, Miss Stewart. All right.
I'm enjoying it.
Yeah, it kind of looks like it might be more rough, but you know, it's really a piece of cake.
It's really not that
It's
bad.
all a matter of rewriting this guy.
Okay.
This is not the derivative. I'm going to rewrite this as 1/3. I'm going to slide this whole guy off to the side. It is really 6x minus 5. Being cube rooted, of course, is the same thing as raising it to 1/3 power.
Very nice. Just
Now,
rewrote it.
It's not the derivative.
Now we're going to take the
Now
derivative.
we're doing the derivative.
Okay.
You can use the power rule again.
Yeah.
This time I have something on the inside. I'm going to need that little chain rule
The chain
action
rule.
going on,
Exactly.
right? So 1/3 times 1/3.
1/9.
Top times top, bottom times bottom. 1/9. Blah, blah, the inside. Remember, I'm not putting the derivative of the inside here. I'm just rewriting the entire inside as it is.
Just like the power rule.
Not the derivative of the inside.
Yeah.
Subtract 1. Then I multiply it by the derivative of the inside. The derivative of 6x is 6. The derivative of negative 5 is 0. And I'm really done here. I'm just going to rewrite it with my negative exponents downstairs.
Yeah, and you can combine those
That's all I'm
numbers.
going to do. So I have this whole guy downstairs. Let's start with that. That is really 6x minus 5 to the positive 2/3. This 9 is really a downstairs 9. I'll just stick that downstairs.
Very nice.
This 6, of course, that's really a 6 over 1. That is upstairs.
That is upstairs.
And then I can simplify it a little bit more. 3 goes into 6 twice, goes into 9
Thrice.
3 times. Would you like me to rewrite that, Miss Stewart?
Sure, why not? Just right next
All
to it
right,
will be
I will write it
fine.
as f prime of x equals 2 over 3 6x minus 5 to the 2/4. 2/3.
And that's your
there
derivative
you have it.
fully simplified.
Fully simplified.
Lovely.
Okay, last one, Miss Stewart.
I'm thinking, wow, this looks like fun.
Well, certainly it's a chain rule because I have a function within a function, something raised, some function raised to some power there.
But I'm seeing the product
But
rule
it's
is
a
your
product.
overarching rule, right?
So I'm going to write down the product rule in case you have forgotten.
Okay.
The product rule, I'm going to write is A prime B plus A B prime. Maybe you do it in a different order, Miss Stewart. I don't know.
I've gone over to the Haas side.
Not to be confused with the quotient rule, I'm going to write that just in case it comes up later.
Okay.
That is A prime B minus AB prime over B squared.
That's the quotient
That's
rule.
the quotient rule.
Right.
A, of course, would be the numerator, B is the denominator. Here, A and B are just the two terms. I'll call this term A, and I'll call this term
B.
Yeah, very nice.
Fantastic.
Very good. Okay.
All right. So
There we
here we go. We're using the product rule.
We are.
I think that quotient rule is going to get in your way.
Oh, yeah,
Let's-
I'm going to erase that.
Okay, good.
For sure. Okay, so the derivative of the first guy, that's a chain rule. Bring the 3 down in front. 3, 9x plus 1 squared times the derivative of the inside.
Which is 9. So that's your
This
A prime.
is just A prime.
Good.
That's A prime. Times the second guy as it is. 2x minus 3 to the 4th.
That's your B.
Yeah, you're right. I'm going to run out of space.
All right.
Okay. This is B.
Okay, there's your A prime B. Halfway there.
Plus the first guy as it is. That is 9x plus 1 cubed
Beautiful.
times the derivative of the second guy.
So chain rule.
Again, that's a chain rule. The derivative of the outside times the derivative of the inside. 2. So this is A, this is B prime.
Beautiful.
Now, you have to practice a bunch of these, but
Yeah.
they really all are the same pattern. I want a factor to help me simplify this guy. So
Right.
I'm looking for the greatest common factor that I can pull out of both these huge terms.
Because right now that's two big terms, right?
It is two big terms.
And usually the way we kind of simplify this is to write it as one big term.
That's exactly right.
So we're
I
gonna
have
factor.
this huge term, this huge term.
So let's see what's
What do they have in common? Well, gee, they both have one of these guys. They both
9x
have
plus
a
1.
9x plus 1.
And I think they both have two of those. So let's
squared,
say squared.
okay. And what else do they have? They
Let's
both have
say-
a 2x minus 3
To the third.
cubed. So let's see what I have left.
That looks
Maybe
great.
there's something else I can factor out
Yeah, but
eventually,
that's-
but we'll see.
That's good for now.
So from the first guy, this is completely gone. Should I
Yeah,
cross that out? And I'm just going to write down what's left. 3 times 9.
27.
I got rid of 3 of these guys, so there's really just 1 left.
Good.
I'll copy that down. I have 2x minus 3. From the second guy,
So
this plus, by the way, is that plus right there?
Yeah, that's an easy one to
Mhm.
forget.
Yeah.
A lot of kids forget that
I
one.
know it.
Plus.
So I pulled out 2 of these guys from here, so there's 1 left.
Very nice.
9x plus 1. I've factored out 3 of this term. Those are all gone. And I have a 4 times 2,
8.
8.
Good.
And I think I can do a little bit of simplifying here. Let's see.
So we're just going to clean up what's inside each set of
That's
parentheses.
exactly what I'm going to do. 9x plus
Those are
2,
already
2
tidy.
x. Just rewriting them. 27. Why did I have to use 27?
Oh, that's all right.
That's insane. Okay.
54.
Thank you very much. 54. Okay. 54x minus
81?
70. Well, is that 81? Yes,
I think
right.
so.
Okay, 81. Thank you.
You're welcome.
Plus 72. Thank you.
See, we're from the generation where we had to memorize our multiplication tables.
Plus 8.
Beautiful.
Right.
Now you're using those big brackets, but those are really just parentheses, right?
Yeah, I mean,
They're just
initially when I
handy so you
factor them
can-
out, I like to kind of, because when I have parentheses within parentheses,
Yeah.
it helps me match them up. But
I
there's
love
no
that.
special meaning there.
Exactly. Good.
Okay. And I think I'm just about done here. Meanwhile, while I'm doing this, are you adding like 52?
No, but
54 and
I will
72?
madly.
I'll work on that one. Okay. Squared 2x minus 3 cubed.
So that's going to be a 96.
96 6? No, I don't think so. That's bigger
Oh, wait,
than that.
126.
126.
126x.
Okay,
Good
thank
thing
you.
somebody's paying attention.
126x.
Let's see,
And
minus
that is
73.
Yeah.
Very good.
Ah.
It's early.
You know, I think 3 is going to go into both of those guys.
But you know what?
No,
we
it's
don't,
not, actually. No,
But,
no.
and also, we don't really have to keep factoring. The idea here is not to have it fully factored, just to have it simplified as
Right.
one nice term.
Absolutely.
And, yeah, so let's look at that beautiful
Absolutely.
thing.
So that's really, that's as far
That's
as...
fine. Even if you could take out another constant, which you can from that last thing, you don't have to.
You know, and just to be, this is not like randomness here. The reason for doing this is because when you go along in calculus, you might have to take the second derivative of this.
Right.
And you really want it in a nice form that you can take the second derivative and then simplify that so that you might want to use that.